Having done parabolas and now circles, let's take a quick look at an ellipse. An ellipse occurs when we take our conic section and we slice through, well, when we take our cone and we slice through a section at an angle. Remember, with the circle we did it was straight across, and that drew us a circle. Now we're cutting at an angle, and that will give us what we call an ellipse. So let's take a look real quick at the equation of a circle. X minus h squared plus y minus k quantity squared, and that's equal to r squared. And let's, for fun, let's set this equal to 1, and we would do that by r squared dividing each term by r squared, so that our new equation would look like x minus h quantity squared over r squared plus y minus k quantity squared over r squared, and that's equal to 1. Now, the way that this equation is written, we can do this, we set this equal to 1, and it works out nicely because our r's are the same all the way around a circle. Let's say that was a circle. Your radius is always going to be the same. It's always the same r. But if you take a look at the ellipse is like if you were to take 2 points on the circle and expand it and stretch it out. So whereas a circle is all points equidistant from one center point, if I were to take that center point and create two foci, two focuses from it, and wheel around those two focuses, those two foci, that would be called an ellipse. And so the standard equation for ellipse looks a lot like the equation for a circle, except that we set it equal, instead of to r squared now, we set it equal to 1. And because we can have a different width than height of a circle, we will divide them by potentially 2 different radii. So a circle, as you can see, is a special case of an ellipse. And let's take a look at how to graph ellipses. As you can see in this ellipse, my x squared term and my y squared term don't have a minus anything squared, right? So in this case, our center point is going to be, like before, at 0, 0. So here is our center point for this particular ellipse. Now we use our 2 different radii in order to draw the rest of the ellipse. So underneath my x squared, I have 16. Which means that from my center point, I'll be moving in both directions, 4 being the square root of 16. So I have another point, 1, 2, 3, 4. I'm going to use this as a reference point, and then negative 1, 2, 4. Here's another reference point. And then I notice that under my y, I have 9. And the square root of 9 is 3, so I'm going to put another reference point, 1, 2, 3, up from the center point, and 1, 2, 3, down from the center point. Now, I'm going to draw a little box, and this box is really just to help me sketch my ellipse. The box is not anything of value. It is not solution to the equations. It's just something to help me sketch my ellipse, so that when I go to actually draw the ellipse, to connect my points via curves, I have some kind of reference point of how to do that. As you can see, this ellipse here opens wider than it does tall. It's got a major axis. It's got a semi-major axis of 4, whereas its semi-minor axis, this axis here, let's even use a different color for that, this axis here is 3. So really quickly, let's do one where we shift our center point. Let's shift our center point this time somewhere into the third quadrant and see what happens if we make one that's taller than it is wide. Here we have to remember that our center point is at negative h, negative k. So our h here is our 3, so the opposite of 3 is a negative 3. And then our k here is a 4, so our opposite of 4 is a negative 4. So our center point goes back 1, 2, 3 before going down 1, 2, 3, 4, and there is our center point. Now, our x radius is 9. Well, radius squared is 9, so I have to go over 3 and over 1, 2, 3. Our y radius is 5, the square root of 25, so I'll go up 1, 2, 3, 4, 5 there, and down 1, 2, 3, 1, 2, 3, 4, 5 there. And now see that we have an ellipse that is taller than it is wide, with a semi-major radius, well, a semi-major axis or a major radius of 5 and a minor radius of 3. Center point at negative 3, negative 4.